Dear friends, in this video lecture, let us discuss about Mach Cone, Mach Angle, and Mach Waves. So, how are they generated, and how we are generating with respect to the different cases, how the sound waves are created, and all those things we will discuss. So, first, let's see about sound waves, and then we will see the rest of the parts. So whatever we are going to discuss in the video lecture. So first, okay. So first of all, we need to understand what is meant by sound waves. The sound waves, okay. Generally, we have to understand from the basic fundamental, because whenever we consider a fluid, within the fluid, if there is any changes in the kinetic energy or internal energy, so all those things are happening because of the pressure force. So if there is a pressure force or even in very small pressure force, so those forces only are responsible for changes in the kinetic energy or and internal energy. So now, okay, so generally, what happened? Now let us assume there is a object or source. So this is what we call it as object. So this is this point. So generally, just we are assuming as object. So so what happened? This is what we just consider as the object, and then yeah. So this is the object. So this is what we consider as the object, and so this object, okay. So around the object, what happens? There will be fluid molecules, or okay, we say that fluid particles. So this object, okay, will be moving based on the conditions. So so if it is okay, we just say that object is having some velocity, then it will be moving. So either okay for forward or okay either to some different locations. So so now what happened? What we need to understand, around the object there will be molecules. That means fluid molecules. It's nothing but gas molecules. So here we are assuming air is surrounded around the molecule around the object. So air is nothing but it is a gas molecule. So within the gas molecules or okay within the fluid particles. So what happened? There will be a kinetic energy and inner energy transfer. So that is okay happens because of the pressure force. So even though that pressure force may be infinitely small, but there will be a transfer, kinetic energy and internal energy transfer. So that is happening, and because of the infinitesimal pressure waves, so what happened? There will be compression waves. So compression waves will be created or generated. So because of the pressure waves, so or pressure force. So because of the pressure force, infinitesimal pressure force, so we are having the compression waves. That compression waves moves forward in the form of pressure waves, sound waves. So that some compression waves only we call it as sound waves. So okay, so that is moving with a speed of sound. That means sound velocity. The sound waves or compression waves are moving with a velocity, nothing but speed of sound, or we say that sound velocity. So now we understood about the sound waves and how the sound velocity is associated with the sound waves. Okay, so the sound waves only moving forward for every time interval. So then that is moving with some value. So that value only we call it as sound velocity. So now let us assume that different cases exist in the flow field. So that means first we are going to assume that object. So based on the object conditions, either it is object is stationary or object is moving faster our object is moving very faster. So based on the conditions, we are going to analyze this problem. So first, let us assume that our sound or source velocity, source or object velocity is zero. So first case we are assuming source velocity as zero. So but there will be a speed of sound. It means because the fluid particles are okay or just around the object. So fluid particles are filled okay. The fluids are okay surrounded around the object, so that fluid will be emanating the sound waves, nothing but the compression waves, nothing but sound waves. That is what traveling with respect to speed of sound. So for the different time interval, how are they moving? So that is let us see how they are moving forward. So I am just drawing the compression waves or sound waves that for the first time interval. Suppose if I say that this is a first time interval, and I'm just drawing the this one. What to say? Sound waves. The sound waves I'm just first for the first time interval I'm just drawing. So now let's see. This is the first time interval sound waves. So we can say that this is the velocity with respect to this. So this velocity, this will have the velocity, and so what to say that velocity we have to just mark it with the help of this one arrow mark, and now let's mark the velocity as the sound velocity. That means this is nothing but the radius. The radius with respect to the sound waves, and source is the source. This is the origin. Source is the origin because now the source or object is stationary. It is not moving. So now anyway there will be a sound waves. That sound waves will be generated. That is what just we have shown it. So this is a, this is nothing but a A. So that nothing but sound waves. This I am marking as the A. That means A, because for the first time interval, this is the sound wave or okay compression waves moved okay with respect to okay sound velocity or speed of sound. So for the second time interval, now let us draw another circle. So that is like this one. So I am just drawing the second time interval circle, and it is something like this. So now I am just drawing the second circle time interval. So when we say this is A, and then this will radius, so that will be nothing but 2A, because now the time interval changes. For the second time interval we are drawing. So this will be like 2A. So just we can mark it with a different color, and yeah. So this is okay. We can just say it is like it is with the 2A. So this radius nothing but 2A. So this, so this is nothing but 2A. Or okay, just we can mark it. Okay. So even this is case. So for the different time interval, so you will have a different compression waves or sound waves similar like this. So this is A, and second circle is with respect to the 2A. So that is okay. We need to mark it. I'm just marking with this one different this one. So this is what we say 2A. So this is what nothing but 2A. We just yes. This value is 2A. So this is 2a. Similarly, if you draw one more circle, so with respect to the another time interval, then that will have a 3a. So we can just draw it, that also not an issue. I'm just drawing as the big circle. Let me try to draw with the big circle. Okay, so it is coming with another this one. So let us, okay, and so now hopefully this is coming. Yeah, okay. So we have got another circle. So this is this we can call it as paired time interval. Yeah, what is this one? So so this is the idea. Yeah. So okay. Yeah. The circle is not coming properly. So this is how we are creating the different sound waves or compression waves for the first case. That means when the object is stationary, how the this waves are the changing, or okay, how these waves are moving forward with the sound waves. That means sound velocity. So for the first one it is A, and for the second one it is 2A, and when for the third one it will be 3A. So that is how the sound waves are traveling forward with respect to different time interval. Now let us assume the second case, nothing but what to say. Second case we can let us assume. Uh, yeah. So second case, we are assuming subsonic flow. It means when the u is okay. This is the second case. I have to just change it. Yeah. So second case, we can just say that is a case two. So case two is nothing but when the flow is subsonic. It means when the speed, that means now still the speed of sound is greater than the what to say source velocity or object velocity. So that is what we describe as the subsonic flow. So now it is this one. So what to say, this velocity is lesser than the this. That means it is so for the second case, so we have a, that means u is less than the this one. So now u is less than the a. That means second case when the object velocity is less than the speed of sound. So how it is going to be, because the object is moving at a lesser velocity, because we know the sound velocity, that is a at every time interval it is means it is moving forward okay by that means addition of every sound velocity. So now okay, the object is okay, velocity is lesser than the sound velocity. So say for example object velocity is 0.5 times speed of sound. So that is how we can just generate. So we are saying that object velocity is that means uh, 0.5. That means half of the sound velocity. So that is what we are just saying. So so here just half of the sound velocity. So we say that u is 0.5 times or half of the sound velocity. So it means okay, if the sound velocity or if the source is moving this much, then your sound velocity is moving twice of the this some value. So now let us assume that our source is coming to this position. That means another position. Our sound waves okay will be much bigger. Okay, yeah, I'm just drawing the new one. Yes. This is okay. So this is yeah, reasonably good. So we can say that yes, yeah. So first sound waves are okay like this, and then second sound waves. This is the value. Okay, this value will be equal to a. Yes. So this value will be equal to a. That means the radius a. That is the a value. That means sound velocity. So this is a. And then for the second time interval, what happened? Your our source will come to. Let us assume that source is coming to this value. Okay, because this much is the okay. This much is the sound velocity. Now for the second time interval, it will be moving half of the value only. So again, the source is coming here. Let us assume that our source is coming to this position. So this is the new position of the source, and yeah, and this is the new position of the source. So this is the sender. Now we need to draw the another next circle. So that means let's try. Okay, uh, the second circle, or okay, second time interval circle. Yeah, I'm just drawing it as yeah. Hopefully this is considerably bigger, and I'm just bringing us. Okay, now what is the idea? This is this one. What to say? Our sender. That means this is the source. So now okay, because this is the second time interval sound base. So now what happened? This automatically we have to just this will become 2a. So we need to just mark it as 2a. Yeah, sorry. Yeah, I'm just marking it as this is as 2a. Yeah. So this is nothing but our second time interval speed at 2a. So so we just yeah, okay. So 2a. This is 2a. So that is what we need to understand. So okay, now we got it as for the second time interval, how the sound waves looks. So this is what our okay for the second case. That means when the velocity is less than the speed of sound, it means subsonic flow. So just we are taking our object velocity or source velocity is half of the sound velocity. So based on that only, what to say, this diagram is drawn. So so this is similarly we can draw for the third time interval, and that will be okay. So that time your velocity again will be sorry, your source will be again will be moved a little forward. That means only half of the value. So half of the value of sound velocity. So and then based on that again we'll be drawing the next circle. So this is what okay in the case of subsonic flow. Now let us draw the diagrams for the sonic flow. That means for the next case. So for the third case, okay, how we are going to draw? Okay, so that is important. So third case, now we have to assume that okay, this is the object. Okay, so this is the object. Now we are saying that our velocity is okay. This is the third case, and let me just erase everything, and then yeah. So this time, okay, you are so you are this, and then this time, so all those things, so are changing means so your velocity and is now okay. So that case we say as the that means this one. So we say is 3 case 3. This is the case 3, and here your velocity is equal to speed of sound, and so yes, so this is the idea. So now source is here, source is here, or okay, object is here. So now this object is moving forward, okay, in the horizontal line, okay, in the horizontal direction. And then now what happens? So how the how our sound waves are going to be? So that is very important. So now let us assume that it is moving with the same okay, same value as that of sound waves or sound velocity. So now I am just assuming that my object is moved from this position to this position. So now just let us mark this is the second position of the names for the first time interval. My object has come to here. So our sound waves also will be what happened same. That means from here to here, the same with the same radius only. The sound waves also will be just drawn. So now let us draw the this sound waves. Yeah, I'm just using the different color for the this one. So okay, now I am just drawing the okay, sorry. Yeah, okay. So this is the first time interval. This one. So because yeah, this is the first time interval sound waves or compression waves, which is moving with the speed of sound. So now okay, and just you have to. This is the velocity. The velocity means yeah. So this is the velocity of the yeah. This is radius. Is nothing but velocity of sound. So this is the idea. So yeah, okay. So now okay, for the first time interval, this is a sound wave, and this is how it's drawn. And for the second time interval, now what happened? Your source is here. Now the source will be again will come to this position, this point. So what happened? This is the second time interval. So that time your speed of sound okay doubled. Speed of sound doubled because that is moving every time interval, that is moving with the speed of sound. So for the second time interval, the speed of the that means radius, that radius will become 2a. So now let me assume that because yeah, so this is the now okay, this will be the sender. Okay, because now the object will come to this position. Yeah, now I am just marking the object below this. So now your object is here. So we have the object. So this is our object. So now I am just drawing the next circle. Means yeah. So it has to be bigger than this. Let me try. Hopefully I am just getting the this one. Yeah. So yes. Yeah. So it will be like this. So what happened? Now your this. So this is your second time interval curve. Okay. So this is like this. So it means yeah, even it should be this distance and this distance should be same. Okay. So let me again redraw it, and then we can understand it much better. So I have to just draw the circle, which is yeah, okay. Hopefully this is better. Yeah, now I'm just yes, yeah, okay. Okay, so the idea is this distance, this radius, and the radius, this one. So both should be same. That means we are marking radius. That means uh, the distance between this and this is nothing but our speed of sound. So okay. So for the second time interval, this is a idea. So okay. So this is how. Yes. Yeah. So yes. So this is nothing but 2a. Okay. So now, okay, this is nothing but 2a. Okay. So similarly, if you draw one more circle, that circle also will be similar like this. Means again it will touch this, and then we will have another circle. So because our source will be moving, okay, we can just say that source is okay moving forward, and the position, okay, we have to mark, and then this is for the third time interval, and then our radius, sound wave radius will be 3a. So that is we need to note down, and then okay, even if you want for the third this also time interval also, okay, we can draw the circle, and let us try, okay, because with the same this is the interval, okay, so this is the okay speed of object, okay. So and just now I'm marking this point, okay. So this will be our next position of the object. So that means same interval, I'm just same value I'm following. That means u value, that means u equal to a. So so now, okay, our object is here. Around this object, now our sound waves, okay, are okay to be marked. So now, how the let us mark with the other color. So that this okay. Now this radius will be 3a because it is for the third time interval. So okay, this is this one. So this is a and 1, 2, and 3. So with respect to this as the radius, then now we need to draw the circle. So let me try, and hopefully just we'll get it, the diagram, that curve, and yeah, it has to be very bigger. So that is one thing. Yeah. So let's see how we are able to get it. Hopefully it is coming. So if it is not coming, and let's redraw it. Okay. Yeah. Okay. I think hopefully it is fine. So it is. This is our third time interval sound waves. So it is nothing but what to say 3 a. The radius is nothing but 3a. Yeah, we have to mark it. So from here, so it is 3a. Okay, so yes, yeah, I'm just drawing. Okay, so this is nothing but 3a, the radius of the this sound. Okay, waves. So this is 3a, and yeah. Okay, so this is 3a. So okay, so similarly we can draw. Okay, for the another time interval, we can draw the another circle. So this is how, okay, our sound waves, okay, are moving forward, okay, for every time interval, and also our object is moving okay with equal velocity as that of sound velocity. So this is about the case 3. So now let us see about the case 4. So nothing but that is okay. We have to see, and let us have a yes, uh, yes. So now okay, yeah, for the third case, okay. So how it is, okay. For the fourth one, fourth case, how it is going to be, okay. So that is what we need to see. So okay, I'm just drawing. Uh, Now I'm just changing the condition. So it will be like fourth case. So case 4. Yeah, this is marking. This is case 4, and then for that our velocity speed of the object is greater than the speed of sound. So it means uh, now the velocity is greater than the speed of sound. So this is also we can just change it. Okay. So this is the idea. So now okay, object moves faster than the speed of sound. So here also let us assume, okay, let us take some value. That means our velocity, object velocity is twice the speed of sound. So let us assume u, the u value is twice the, and just here I am assuming u is equal to twice the speed of sound. So twice the speed of sound. Yes. So now okay, that is the idea. So object is moving for every time interval. Object moves okay forward twice that of the speed of sound. Okay. First, let us consider first time interval. So what happened? First time interval, object is moving from this position to this position. It means this is with respect to twice a. That is the idea. So I am just marking this point. Yeah, this object locations, and now okay. With respect to this, we need to draw the sound waves or the compression waves. So okay, now what happened? Object velocity is greater. Object velocity is greater, and sound waves are okay. Means smaller. Means sound waves velocity value is smaller. So let me draw the circle with respect to this condition, and let's see how it is looking. So now okay, so I'm just drawing the circle. Yeah, okay. Hopefully it is okay. Coming. Yeah. Uh, okay. Uh, yes. Yes. Uh, yeah. So this circle. Now let's see. Yeah. This is. Still I can enlarge it little bigger. Yes. Okay. So this is the idea. Okay. For the first time interval, what happened? Our source has moved from this position to this position. Means from A to B. So let us mark this is the A. That means okay. So that means so this is the A, and this is B. Okay. So I'm just marking as object position. This is A, and this is B. Mm. Or 1 and 2. So we can just mark it as 1 and 2, so that it will not be confusing. Okay, because A we just take it for speed of sound. So 1, and this is the object position for the first time interval, because object is moved from this position to this position with a value, that means with the velocity which is greater than the speed of sound or double the okay, for our for in this case particular case, we are assuming that twice that of speed of sound. Okay. So now this is a first time interval. We got such kind of sound waves or compression waves. So here we can just see here, okay, because this is the thing. So and here we just the radius we can see the radius is nothing but smaller. Okay, so it is smaller, and we can just yeah, this is a, this is nothing but a. So yes, so this is nothing but a. So now for the second time interval, now let us draw. So that time what happened, where is our object? So first that we need to mark down, mark it, and then we can just draw. So okay, so I'm just, okay, yeah. For the second time interval, I'm drawing the sound waves, nothing but compression waves, how they are moving forward. So that for the second time interval, what happened? Your the sound, the radius or the sound velocity, that will be twice that of this one, because it is for the second time interval. For each time interval, it is traveling with the speed of sound. So that is the idea. So now we need to draw the next circle. Yeah, I'm just taking a red color and marking and just drawing. So now, okay, first before that we need to locate or mark our object location. So this is the A, and for the second time interval, what happened? Object will come to this position. Means object is okay at this position now. So yes, so this is the object location now. Okay, so object is yeah. Okay, so this is the object location. Okay, so now that we can mark it as 3. Yeah, yes. Okay, so that we can mark it as third position of the means yeah, third position of the object. Okay, so now we need to draw the what to say, sound waves around this object. Okay, so that is okay with the velocity twice. Okay, means our sound waves will have a value which is lesser. So this is A, and second will be 2A. So that 2A with the radius 2A, we have to draw the circle. I'm just drawing. Uh, yeah. Okay. This is this one. Now let us draw the circle. Yeah. Yes. So we can just say that this is our okay second circle. Okay, and yeah. Now I think hopefully this is uh, yes. Okay, then we can just have it, yes, because this will be 2A. So that is the idea. So now I have drawn the second time interval sound waves, and this will be a 2A. Okay, so I'm just we have to yes. So this will be 2A. So because now the object is moving faster than the speed of sound. Okay, so this is the second time interval, and third time interval, how this sound waves okay looks, and also where is our object, so that we need to locate. So for the third time interval also, object will be moving twice that of the okay speed of sound. So now okay, this is speed of sound, okay, twice means okay, this is twice. So now I can just mark. So this will be the next position of the object. So I'm just okay. Let me use a black color. So this is the next position. Okay, at this position. Okay, now our object. Now for the third time interval, our object has come to this position. So now let us mark this as position number 4. So this is fourth position. Okay. So okay, and okay, by keeping this as the sender, now we need to draw the sound waves for the third time interval. That means by keeping 3 as the radius, we need to draw the circle. So let us draw the circle with the help of this different color, and yeah. So yes. Uh, So okay, we have to draw the circle in such a way that it has the 3a. So the radius would be 3a. So now let us just keep it as this one, and yeah, okay. Even still this is not this one. So we have to enlarge it. Yes, yeah, yeah. Okay. So that means yeah. Okay. Okay. So that means okay. This is nothing but 3a. So that is the idea. So now we have drawn the. That means yeah. Now we have drawn the um, third in time interval sound waves, and let us mark that radius. Uh, let us mark the radius. So this will be our okay. Yeah. So I'm just marking. So okay. So here this is our 3a. That is a okay idea. So this is our 3a. Okay. Yes. Okay. So this is our 3a. So this is how okay for the supersonic flow. Because here our velocity is greater than a, nothing but supersonic flow, and here we are considering for this particular case, we are considering the object velocity is twice that of speed of sound. So that is the idea. So now okay, we need to complete this diagram. So this initially our source was here. So initially our source is here, and then later on only it is okay moved forward based on the conditions. Based on the conditions, it is moved forward. So our source is here. So by taking as the starting point, now we need to draw the tangent to all the points. So if you draw the tangent, so what will happen? So our curve will be okay. Our line will be something like this. Just we are drawing the tangent. Okay. So let's draw the tangent. Yeah. Yes. Yeah, I have just drawing the tangent. Okay, hopefully it is yeah clear. Yeah. So okay. Yes. Okay. So this is better, and then so other side also we have to draw the same curve. Yes. So we have to draw this side also in the similar fashion. So our yes. So this will be looking like this. So that is the idea. Okay. So okay. Yeah. Yes. So yes, this will be looking like this. This curve, okay, should have come slightly this one. So that is why it is not okay. So we have not taken perfect this radius, and so that is why it is slightly deviating. So otherwise, this will be touching. This curve will be, or this line will be touching all the sound waves. So and then this is how okay we are just completing this diagram. So here we have to understand our source is here, and then it has moved to a different position based on the conditions what we have assumed. So within this region only, whatever happens. So if anything happens, okay, that can be heard. Okay. So outside this curve, outside this line, so that we cannot hear any sound or anything. So so that is what okay. So here, whatever happens within this cone. So this is like a conical section. This entire this one, the line what we have drawn with respect to the sound waves, okay, above and below the reference line. So that is okay, gives such kind of shape. That shape is nothing like a conical shape. So that is why we call it as it is like a cone. So this cone only we call it is like, that means called as Mach cone. So the Mach cone, now we have to just note down few things. So as I said, only within this lines, within this Mach cone only, if anything happens, so that can be heard. Otherwise, suppose if there is a sound, okay, or if there is a disturbance here or here, wherever it is, then it can be heard. But outside this Mach cone, so nothing can be heard. That's why. So inside, whatever happens, so that is we call it as zone of action, and outside the cone, whatever is okay, which we are not able to hear anything, that is anything of the object or okay presence of the object. So that is we call it as zone of silence. So now let us find out the Mach angle. So for finding the Mach angle, we need to draw on this one, and just drawing the this. So here is it is like yeah, this. Okay, I'm just drawing the line from here to here. Okay, so yeah, from here to here, I'm just drawing the line. So and then yes, okay. So let us take okay, uh, okay. So this is okay. Okay, so this is okay. Then this line, so nothing but what? This is what we call it as speed of sound. Okay, so so we can just say that this is nothing but A. Then for okay, we just this is for the third time interval we say. So anyway, for if you take any time interval, so this would be the radius. The radius is nothing but speed of sound. So we can just mark it as this one. So let me just mark the value. This is the A, and yeah, and yeah, this one. This is nothing but A. So the distance between this point to this point is nothing but A, and the horizontal distance between this position to this position. So nothing but what? That is nothing but object velocity, because that is what object has moved. Okay, so generally we can take it as this is nothing but we can just say that object velocity. So the distance between these 2 points are nothing but object velocity. So yeah, now we can just yeah, I'm just marking as this is nothing but u. So what? This is nothing but u. So if you say this is a and this distance between this point to this point is nothing but u. So now this is like right angle triangle. So our 90 degree is here. So 90-degree angle. Just we can just say that this is 90 degree. So this is a 90 degree. So okay, so like, this is like a right angle triangle, and so this is a right angle triangle, and this is our base, and this u is nothing but this side is our hypotenuse, and this is the what to say. This is the angle. This is the opposite side. Yeah. So we can just take the angle. We can just mark the angle, that angle, and just marking it as this one. This is the A. this is nothing but alpha. So yes, so this is nothing but alpha. So this angle only we call it as a Mach angle. So angle between this horizontal line and this inclined line, which is which is tangent to all the sound wave circles. So that between that angle only we call it as Mach angle. So now, just we have got the Mach angle, and this Mach angle can be represented in terms of Mach number, because Mach number is nothing but we know it is speed of object divided by speed of sound. So here alpha, so that is equal to opposite side by this one. So this is the opposite side, and this is nothing but our hypotenuse, because when you consider this as an angle, and this will be a hypotenuse. So opposite side by hypotenuse is nothing but what? So that is thing. Or even we can just say that this angle, yes, yeah. So I'm just taking. So for that is nothing but sound sine theta. That means sine. We can just say sine. Yes. So this is nothing but sine u, or generally this is not alpha. We used to consider as the mu. You can take it as whatever I have taken here. So just nothing but alpha. So if you take this is alpha, then it is equal to sound waves. That means sine alpha equal to opposite side by hypotenuse. So that means a by u. So this is nothing but what? So we know well Mach number. This is nothing but 1 by m. So that is the idea. So this is nothing but 1 by Mach number. So Mach number nothing but capital M. So so our alpha equal to sine universal 1 by m. So that is how we are getting the Mach angle. So, so this is what about Mach angle and Mach cone and Mach waves. The Mach waves is nothing but the sound waves. Okay, the sound waves only are called Mach waves. So the Mach waves only is the weakest weakest strength, or we can say it is the strength wise it is very less. So it is the weakest wave in the shock waves. So or we can say weakest shock wave. The Mach wave is nothing but a weakest shock wave. So this is how we are completing this lecture, and we have obtained our Mach cone, and we have drawn the all the circles sound waves and how they are traveling with respect to the conditions, either it is subsonic, supersonic, or sonic. So with respect to all those things, we have seen how it is traveling, and how the sound waves are varying with respect to different time interval. So hopefully you understand this concept, how we have drawn the Mach cone, and how we have found out the Mach angle. So if you have any doubt, please let me know, and you can just put it in the comment box, and we can have a more discussion on this. So okay.